Welcome to my video. In this video I want to take this tomato and this copper electrode and this zinc electrode right here, and I want to make a battery. And then I want to use my voltmeter to determine the voltage out. And then I'm going to put a 1K ohm resistor, 1000 ohm resistor across it to determine what that does to the output voltage. That'll be the loaded voltage is what we would call that. And then from that, I'm going to calculate how much power this thing can deliver. So that's what I'm going to do. So first of all, set this aside. And then I'm going to insert the electrodes, put them about 1 inch apart. So this is the copper electrode. Put that in there. And then this is the zinc electrode. We don't want them touching deep in the fruit as you can, possibly without. And oh, by the way, I've got those electrodes. They came from this fruit battery science experiment kit I did an unboxing on. So that's where those came from the EUDAX company. So we've got that hooked up. Now, what I want to do is let's determine the voltage. I've got this on the volt scale on my volt ohm meter. Now we'll hook this up. Let's go red to red and see what it's going to be. The copper is going to be the plus electrode and the zinc is going to be the minus. So that's all right. It's just going to measure different. Let's give us a negative sign. All right, so let's see what this does. Okay, so it gives us minus 1.67. I'm going to write that down. Minus 1.67 volts, and that's open circuit. Now we're going to change that, and we can see since the copper is basically the plus electrode, and so I've got it going into there. So that's the zinc. That's why we're getting a negative voltage reading here. If I reverse these leads, it will change the polarity of that. Let's just do it that way, just so everybody's doing positive voltages here. So there it is. Voltage not changed. Now what I'm going to do is I'm going to put this 1K ohm resistor as a load. And you're going to see the voltage drop. And we're going to record that. And then I'm going to make some measurements. So I'm putting this thing under load. In other words, it's going to draw some current now. So it's going to change the properties. So let's see, so that goes over there. We put that on that side. And that goes right there. So now we're measuring the voltage. And you can see the voltage has dropped significantly. Now this is on the millivolt scale now, so it's 194 millivolts. It's dropping. So it went down to 194 millivolts. That's a big drop. That's with the 1K ohm. So I recorded those numbers on there. Now what I'm going to do is we've taken our measurements. We know the open circuit voltage, that was 1.67 volts, and then under load it's continuing to drop as the electrolyte is being used up with under the 1K ohm resistor. So let me do some calculations next. I'll be right back. Now I'm going to calculate the current and the power associated with that battery. So we know the current is equal to voltage divided by resistance, just due to Ohm's law. So this is going to be the voltage under load, and we saw that was 194, that's volts. It dropped quite a bit, divided by 1,000 ohms. So let's do that in our calculator here. So I have got 0.194 divided by 1,000, enter. So that's equal to 1.94 times 10 to the minus fourth, and that's going to be units of amps. So it's a very small current produced by this battery. Now, if we want to calculate the power is equal to voltage times the current, and the voltage out was 0.194 volts. And then the current we just saw is 1.94 times 10 to the minus fourth. That's amps. So let's take that number, it's in the calculator there, times 0.194, enter. So what we're going to get is the power out 3.76 times 10 to the minus fifth, and that's going to be in units of watts. So we can see this tomato battery did not produce a lot of, it's a very small battery, very small amperage, down the microamps, and then down in the microwatts region. So not a huge battery, but it does work. So I hope you learned something about this battery and how to use it, and how to make a simple battery from a tomato. Thank you for watching.